Hello, my name is John Riley, and I'm just going to go over my Capstone project for EDU 710 for Central Michigan University. And I designed a project for my software development and programming section of my class. So kind of go over this presentation about it and then show you the actual site. So this all started with the problem of practice that we have that the software development and concepts is one of the lowest scoring sections that our students historically have had when they take the IT Fundamental Certification Test. And so really wanted to improve the scoring on that section. And a lot of that has to do with the vocabulary and the terminology that's all new for students. And so I thought by developing some hands-on projects that involve these concepts and this vocabulary, the goal would be to increase student performance in this objective of our certification test. Just some supporting research that I liked about this. Coding can be a difficult thing for students to understand. It's a difficult thing for me to understand sometimes. So I think the idea of learning taking place in small chunks, breaking things down, having students, showing them something and then having them work on that and kind of gradually building up. So that's how this project was designed. The collaborative aspect of coding, especially when things aren't working and being able to check in with other people. So students definitely have the opportunity to do that, to work with other teams and teammates in order to get this done. Just the retention level as well of me standing up there and talking about it and demonstrating it has about a 50% retention level, where instead if I have students do something hands-on and demonstrate that what they're learning, it's a much higher percentage than that. Drones are a real-world technology, and it really gains student engagement, student interest when we do this. So bringing that aspect into and matching it up with programming, which when students hear that term, sometimes they're immediately turned off from it. So I think bringing those two together helps with that engagement. And then we also use Lego Mindstorms in this project. So there's a lot of careers with the programming of robots and machines and things like that. So it really brings in some real world challenges when students use that. Just some ISTE certifications, how it's linked to that. So how does your capstone apply to the EdTech vision of your organization? Going along with our organization, trying to use as many different forms of technology as possible. So this is using microbits and Lego Mindstorms and drones, but also using other websites, and they have to record video and do a bunch of different tools. So there's a lot of different technology being incorporated in this one project. ISTE E5B, what content area standards are applicable and how will they be noted? So I got two sets of standards. One is my system administrator. The zip code for that is 11.1001. So we use that for our funding from the state. And so there's some standards in there about planning and time management. So this project is all about that, but they have to kind of plan out and develop what they're going to do ahead of time and use some project management skills. And then the other side of it is compare classes of software associated with development and maintenance information systems to develop software and maintain computer systems. So they're going to use a bunch of different languages, have a bunch of different examples of languages, and we're going to start out small and progress through, ultimately ending with Python. The other side of this is we have our certification objectives and standards that we go by. And so those are posted earlier, but using a lot of those as well for this project. All right, so the outcomes for 5B, I want students to develop their own goals and outcomes for the project. I want them to develop timelines, so they have to use some time management skills and figure out how long they're going to spend on each thing and to make sure that they can get done. Those project management skills to plan out which teammate is going to do what and assign some responsibility and roles. I want them to explore the key functions in the software that they're using to complete the task. I want them to be able to summarize what they have learned and use a checklist to be able to track that. And then I'd like for them to explore drones and robots and program them accordingly to a set of preset goals. So how will I personalize the learning, engaging and empowering students with voice and choice on process, product, and platforms? In the LEGO Mindstorms and Microbits projects, students have choices and the freedom to program those tools according to the team's goals. Programming drones is an engaging activity that teaches students how to fly a drone and how to write code so that it will complete the obstacle course. And then they publish their results online, so they can use Padlet or Wakelet to do that, or if they have something else they would like, they can choose that. Just engaging. So overall, these projects are very engaging. Students get to use things, manipulate them, design their own projects. So that's engaging in itself. But then you put drones in there, and that's also a very engaging activity. One thing I'd like to note in here is it says, where does the technology cause a shift in the behavior of students, where they move from passive to active social learners? So I actually have the problem where when we're flying drones that everybody wants to do it at the same time, and partners kind of fight about whose turn it is. So we developed this like battery technique where each student is in charge or the leader as long as they're using the battery, and then they have 10 to 15 minutes of flight for each one. Does the technology tool aid students in developing or demonstrating a more sophisticated understanding of the content? So yeah, instead of just learning basic programming terminology, this goes beyond the curriculum requirements. And so the entire project's based on creation and production that they have to do. It's designed to start small, and slowly build up those skills so that they can complete the different projects. And for students to demonstrate their understanding of the learning goals in a way they could not with traditional tools. So they record their projects and explain them online. And then some of them are actually demonstrated in person, and they get live feedback right on that right away. Triple E Extended. Does the technology create opportunities for students to learn outside the typical school day? I mean, there's a ton of coding resources that I have posted and things that they can do outside. Unfortunately, the resources we have are only available at school, so that is a challenge for sure. Just some support for ELL or struggling students. They've got closed captioning on all the videos that are posted from YouTube. They have noted times to use screen readers. They get to select their own projects, so they can, if they're struggling, they can select a little bit easier projects and still meet the goals. And then if they pick things that are too easy, I can challenge them to do things that are more challenging or difficult. They're in predetermined teams, so I base them on ability level and try to put a student who may struggle a bit with a more advanced student so that they can kind of learn from each other. So that helps them how to solve problems and use teamwork along the way. Assessment of learning, so like I said, they have a video that they turn in. They have a checklist that they have to submit for each step, so they've completed each thing. They have a reflection piece for each part of the way, and then they, on time trial day with the drones, are actually going to fly their drone for the entire class, get feedback that way, and the results are very easy to see based on how far they make it through the obstacle course. All right, just some work cited here, and then my actual project. That up. So this is my website here. So it's kind of divided by projects. So Lego Mindstorms, Microbits, some Python content, and the drones. The nice part about the Lego Mindstorms and the Microbits is that they can be worked. Half the class will do one item and the other half will do the other. And then they kind of switch. So that creates some time management areas, but then also they have people they can rely on in the class who maybe have already done the projects in one, and they can ask them questions. So they have a checklist to go through along the way. Looks something like this, where they can kind of go through each project. So A, B, and C. They're assigned a project here. What they do, the other ones they're going to come up with, and then they have to answer some questions on those. For Microbit, same thing. Python, they have some stuff they have to do, and then the drones as well. So That's how we'll track their progress. These are certification objectives that we follow, and just a little overview. So Lego Mindstorms, we have these kits. They're going to build the Legos. They're going to spell out their name after they've made something that can drive, and they do that all with block-based coding. So it looks something like this. And there's directions and resources to help them along the way with building that. Microbits are these little computers. Basically, they have a bunch of sensors and LEDs that are tied to them. So they have to have the LEDs spell out their name, and then after that, they design or develop some projects of their own that they want these things to do using a whole kit of sensors and things like that, and post it. So here's kind of that if they want, based on their grade, how many projects they need to complete, and then if they want an A, at least one has to use some basic Python. There's a little bit of Python practice in here with some terminology, and then some smaller online projects they can do. This can all be done at home. And then we get to the drones themselves, where they learn to fly the drone first, and then they've got to go through an obstacle course on here. This is kind of what it looks like. So this is not using the block-based programming, but instead it's using Python. And so this project, they used all distances to calculate how far it is to go through each obstacle, and then had the drone fly each way. So this one is pretty good. So they're also had a grade based on the amount of lines of code that they use, and then the time that it takes for the drone to fly through the course as well. Then just some additional resources. We've got Quizlet practice on the different objectives, some Lego Mindstorms tutorials on and directions on how to build the robot, and projects that they can do. And then the microbit, same thing. They have a starter kit that has a bunch of project ideas in it that they can use if they'd like to, and some additional Python resources as well. So yeah, that's what this was for. Our ed tech goals for our district, our SIP code gap analysis standards that we use, and then just some accommodations for other students. So yeah, that's basically the project. Hope you enjoy it, and thanks for your time.